Alright, I think I got cut off on that last video, so I'm just going to finish up. We were using Hero's formula for Unit 26 to find the area of a triangle. And first of all, we found S, which is the sum of all the sides, so we added up all the sides times 1/2, that's 11.58. And then we were plugging them into the formula, this formula here, S, so I take everywhere there's an S, I'm going to put an 11.58, that's the sum of the sides divided by 1/2, or times 1/2, divided by 2. And then I take that and subtract each of the sides from there. So then when I plug this into my calculator, what I get is the area equals the square root of 386.093. And this actually ends up being meters to the fourth, because this is a meters, this is a meters, this is a meters, this is a meters. So the label is meters to the fourth. So then I'm going to take the square root of that. So then the square root of 386.093 is 19.6, and the square root of meters to the fourth is meters squared. So the actual question, though, if we look at it for part A, this is just part A, find the area, then they ask us to find the altitude, JK. So they're asking us now to find this value right here, JK. JK. Well, we can do that now, because now we know that the area is 1/2 base times the height. That is the other area formula that we know. We just found that the area of this was 19.6 meters squared. We do know that the base, if I use this as the altitude, the base is the one that the altitude hits. So the base is 10.2, and then we can find the height. So we now have an equation that we can solve. If we multiply 1/2 of 10.2, that is 5.1, and that's meters. So 5.1 meters times the height we're looking for equals 19.6 meters squared. So to get h by itself, I'm going to divide both sides by 5.1 meters. And I get that my height, or my altitude, that's JK, that's your height, is 19.6 divided by 5.1, and that is 3.84, and meters squared divided by meters is just meters. So that is the answer to part B. All right, and that is all the notes for Unit 26. I'm going to just keep going here with some volumes of solids, which are nice. This isn't on your assignment sheet, but we're going to cover this. I've added some new problems to the assignment sheet. These are not at the end of the units. These are kind of in the middle of the units, and I want to make sure you don't do the examples that are already worked out, do the little exercises. But we aren't really covering surface area of these figures, so that's why we aren't going to do everything at the back. So starting with Unit 28, 29, and 30, really they're kind of all just mixed together. They're basically, we're just looking at volumes of some different things, and volumes are pretty simple. So page 604 and 605 is where you can look in your book if you want to see some actual pictures. But we've got a prism, volume of a prism, right or oblique. A right would be something that was straight up and down, oblique is slanted. So a prism is basically, it's like a box, okay? So basically you're finding the volume of a box. Okay, a prism, I just think of it as a box. Now the box could have different shapes of bases. The box, it could have like a triangle base. It could have a square base. It could have a hexagon for a base, but there's lots of different things. So here's just a picture. These are just some of the different types of prisms. These are examples of prisms. So the volume of a prism, any of these prisms, can be found by taking the area of the base, which is the letter that they use for that is a large A, and actually they just use a little b. So instead of this, they use like a large A with a little b. And no, they have a capital B here, I guess, but it's real small. So area of the base is represented by A with a little b below times the height. So this is the formula for the volume of any of those pictures I just showed you. Now the key is the area of the base is different depending on what the bottom is. So if the base could be any of these shapes. So the base could be a rectangle, in which case its area is length times width. Hexagon, pentagon, there's they look like fancy formulas. Basically a hexagon, or we'll just take a pentagon to be simple. Okay, the center of a pentagon, if you draw, lines, you end up with 5 triangles. And each of these triangles has the height right here, and that's all the same height. And then this little thing here is the base. So if you can find that, they call it the altitude times the base, and multiply it times 5. So 1/2, so basically this is a triangle. So we're going to find this area by taking 1/2 the base of this times the height. So that's the 1/2. The base of that triangle is the side, and the height is the altitude there. And then times 5, because it's a pentagon, times the number of sides. So you aren't going to see those very often, really. I just thought I'd throw them in there. A triangle, whose area would be 1/2 base times height. The area of a square could be the same as a rectangle, length times width, but they call it side squared sometimes. And a circle, if you have a circle as your base, then your prism, it's not really called a prism anymore, it's called a cylinder. Okay, so cylinder, the bare area of the base is a circle, so that's pi r squared. All right, so just some quick examples here. Page 606, number 2. This is actually one of the, from the problem section. So it says compute the volume of a prism with a height of 26.500 centimeters and a base of 610 centimeters squared. So what they actually just give you are the values that you need to find the volume. The volume is the area of the base times the height. And so the area of the base, they tell you, is 610. They just tell you that. And then there's the height. So you just multiply them. So 610 times 26.5, and that gives you 16,165 centimeters cubed. And how do you get cubed? Because the area of the base, the area, remember, is always a square unit, times another unit is a unit cubed. Volume is always units cubed. All right, so now we're on page 606. We're going to look at number 8, and we're excavating a building, so we're digging out dirt so we can build a building. And the hole that we dig is 14 feet deep, 35 feet wide, and 60 feet long. And imagine it's like you just dug a big box of dirt out. We want to know how many yards cubed of soil are removed. That's finding the volume of that box. So the volume of that box, if it's 14 feet deep, and 60 feet long, and 35 feet wide. I'm trying to kind of draw three-dimensional here. Okay, this is like the box that you just dug out of the ground. So if you can imagine the base here, this is the base, okay? So the area of that base is a rectangle. So the area of the base, so the volume is going to be the area of the base times the height or the depth, okay? So the area of the base is going to be 60 times 35, because it's a rectangle, length times width, times the height, which is 14. Some of you may have learned the volume of a box is length times width times height. Well, it really is, okay, because the area of the base is length times width. So 60 times 35 times 14, it gives me that the volume is 29,400, and this would be feet cubed, cubic feet of soil. All right, so now we want to know how many truckloads to haul all of this soil if the average truckload is 3.5 yards. Oh, and they say yards cubed. Let's see, what did I copy? Wrong here. Oh, yeah, we need cubic yards. So we're going to have to change this into cubic yards. So we need to get our little conversion things out. And how do I change into cubic yards? All right, so 1 cubic yard, 1 yard cubed is equal to 27 feet cubed. Okay, so I basically need to take this and I need to divide it by 27, and that gives me that my volume is 1,088.89 yards cubed. So now, knowing that, I need to split this up into loads of 3.5 yards cubed each. I basically just need to divide this, 1,088.89 divided by 3.5, and that's going to give me that it's going to take about 312 loads, 312 trucks or loads to get rid of all of this dirt. All right, so now let's take a look at Unit 29. In Unit 29, we're looking at a volume of cones and pyramids. So volume of a cone or pyramid. Let's take a look on page 619 at number 4. The volume of a cone is 1/3 area of the base times the height. And that's just a cone here. So if we just take a look at page 619, number 4, this is on the very bottom of the page. It says the container is in the shape of a right circular cone, which would be this. This is a right circular cone. They're assuming it's not slanted. So this is the kind of picture we have. When they say right circular cone, we're talking about this is going to the center of the circle. This is a right angle here. All right, so the base area is 4.8 square feet. So we already know that that is 4.8 feet squared. That's the area of the base. And the height is 1.5 feet, so that's 1.5 feet, and that is the height. Compute the capacity of the container in gallons. Okay, so we're going to have a little conversion here to do at the end. So the volume is going to be 1/3 times the area of the base, which is 4.8 feet squared, that should have been feet squared, times the height, which is 1.5 feet. So when I multiply these, the volume is going to be feet cubed. So I'm just going to take 4.8 divided by 3, multiplying by 1/3 is the same as dividing by 3, times 1.5, and that's going to give me 2.4 feet cubed. And then I need to change that into gallons. All right, so what we have is, I wrote the conversions down here. We have 2.4 feet cubed is how much this will hold. We want to change it into gallons. So I found these two conversions. This is the one we're going to use. We need to get rid of the feet cubed and change it to gallons. So to get rid of the feet cubed, I need to actually put the feet cubed on the bottom. So 2.4 feet cubed, for the conversion, 1 feet cubed is 7.5 gallons. So by doing this dimensional analysis, the feet cubes cancel, and the operation, since both of these are on top, is multiply. So 2.4 times 7.5, the volume is 18 gallons. All right, so I'm just going to jump to the sphere. We're going to skip this example so we have enough time. So Unit 30, the volume and surface area of a sphere. So the volume of a sphere is like a ball. Okay, the radius goes from the very center out to the edge. And so the volume of the sphere, all you need to know is the radius. You take 4/3 times pi, and you can use 3.14 times for pi, or you can use the pi button times the radius cubed. The surface area of a sphere is 4 times pi r squared. So we're on page 635, and we are going to look at problem number 2. And basically it just says use the tables to round. Let's see, we want to find the volume, and we're just going to find the volume and surface area of a sphere. So I'm kind of adding on to the problem. So we're going to find the volume, and we're going to find the surface area of the sphere. And so for number 2, it says it has a 28 centimeter diameter. Okay, a diameter is all the way across, so we only need half of that. So the radius is 14 centimeters. So the volume is going to be 4/3 times pi times 14 to the 3rd power. And the surface area, we better give that a better letter than V. The surface area sphere we'll call S. So how about we do that? So surface area of a sphere, S would be 4 times pi times 14 squared. So all I have to do is take 4 divided by 3 times pi times 14 to the 3rd power, and for the volume that gives me 11,494 approximately. That's rounded a little bit, and this is going to be centimeters cubed. So then if I work out the surface area, 4 times pi times 14 squared, the surface area is 2,463 approximately, and that's rounded, and that is only centimeters squared. All right, that's about all the time I have for units 28, 29, and 30, but it's pretty easy. I'm going to add another video for the last few units, so we'll have all the last few units on video.